Hi, this is Chris Parrish. I'm a professor at Oregon State University. I'm here at the NOAA Aircraft Operations Center to take delivery of the EARL-B bathymetric lidar system. I'd like to thank NOAA's Aircraft Operations Center and NOAA National Geodetic Survey Remote Sensing Division for donating this equipment to us. So this is the EARL-B, the Experimental Advanced Airborne Research Lidar. It's an airborne bathymetric lidar system. Currently, there are no educational programs in the US where students can get hands-on experience, not only with working with bathymetric lidar data, but more importantly, actually working with the systems themselves. So we feel that by training the next generation of students in this technology, we'll really be able to drive the whole bathymetric lidar industry forward. This is truly an amazing technology. I've worked with this technology for approximately 25 years now, and it never ceases to amaze me that you can fly over an area in an airplane at 300 meters and map very detailed, accurate submerged topography, also known as bathymetry. So the way this works, this system will actually be installed in an aircraft. And so there's a hole in the aircraft, and there's a laser system, which is sending laser pulses directly down towards the water surface. So it's a green laser, which is good for being able to penetrate through the water column and get returns from the seafloor. And so what happens is that each one of those laser pulses comes down, is bent into the water column, reflects off the seafloor, and then travels back all the way up to the aircraft. And by measuring very accurately that time of flight from the aircraft down to the seafloor, you can get a distance measurement. And then that gets combined with GPS and inertial navigation sensor data on the airplane to be able to produce very accurate spatial coordinates of points on the seafloor. So the EARL system, going back to the original EARL-A and then continuing on to this EARL-B instrument, was active from 2001 through about 2015, and it was used for a really wide range of science and application uses, from safety of marine navigation to looking at changes in coral reefs over time to doing pre and post storm analysis. So this is one of the two cameras that would have flown with the lidar system. So in addition to collecting the lidar data, which gives us elevations of the seafloor, we also want to be able to capture imagery at the same time. And there are two cameras that are used. One is just like the camera on your cell phone, a little more sophisticated, but a regular red, green, blue camera that collects data in the visible portion of the spectrum. And then the other is a near-infrared camera, which collects data at slightly longer wavelengths than what we can sense with our eye. But both of those together are really useful in combination with the elevation data from the lidar for mapping coastal areas. So one of the real benefits of topobathymetric lidar is that it is very time consuming, and it can actually be dangerous to have ships and small boats operate in very shallow waters, particularly if you've got areas that are maybe high wave energy environments or around coral reefs or rocks or other submerged hazards. So with a system like this, you put it in the aircraft, you're keeping people out of harm's way by collecting all of the data at about 300 meters above ground. And you can actually collect very dense, accurate data very efficiently with a system like this. And this is actually one of the reasons why this particular system was built. So in the early days of bathymetric lidar, a lot of the systems were designed to really map deep. And so they wanted to get out into the areas, 50, potentially 60 meters in areas of really clear water. This system was designed with different objectives in mind. So a lot of it was really focused on scientific applications and being able to get very dense data in the near shore, so shallow water areas, 0 to 10 meters, but get very spatially dense, accurate data in that area that would support a wide range of science and application needs. So this is Chris Parrish from Oregon State University. Thanks for watching.